Hello everyone, today we are going to talk about how to get a stable reading from HC-SR04 ultrasonic sensor. And here you can see we get a very cheap ultrasonic sensor which is very famous to configure with the Arduino Ultrasonic, but we are getting a reading on OLED screen. Here you can see the reading is not stable and it is continuously changing. I will show you into a plotting on the serial plotter as well, but here you get the idea that reading is not very stable. So we will try to match how to get a stable reading from the ultrasonic sensor, especially when it gives outlier, which is sudden change in the reading, but the continuous distance is not that much changing. So let's get started and see how the actual stabilization will work in our case. And let's move to the wiring diagram. The wiring is pretty simple. We are going to use the SCL SDA with the respective Arduino UNO pins, and we are going to use the trigger and echo pins on pin 8 and pin 9. So let's move to the code. This is a code which we use so far, and we are configuring the OLED screen. Then we are getting the trigger and echo pins, and after that we are initializing the serial port, and inside the serial port we are just getting a trigger and echo pin respective high and low, and then we are reading the duration of the echo, and by this formula we are calculating the distance in the centimeter, and we are plotting on the serial monitor. So let's see how the changes is being done on to this screen. And if we open up the serial monitor, you will notice if we change the baud rate to the respective 9600, and you will see the reading like this. So that's the reading we are getting. Now I opened a serial plotter, and I am putting this sensor to test, and I am changing the ultrasonic sensor, and here you can see the random plots. And if I open up the camera, and here I will put them side by side to see the idea of how I am changing this. So as you can see, we are getting a pretty much noise in the reading, and the main concern of our today's tutorial is to remove this kind of sudden noise. Here you can see this is a sudden spike which we need to remove. Here you can see we get another spike, and we don't want these kind of spikes in our stable reading. We need a pretty steady reading. So what the solution? We are going to use a median filter. I had already explained the exponentially moving average filter as well as the moving average filter and their comparison in my one of the previous tutorials. Today I'm going to explain how the median filter is used to remove these kind of outliers. Okay, so let's see how this filter will be working. Here you can see that we are getting some noise value which is 24, 24, 25, 25, which is correct, and then suddenly we get the value of 250, which is not the actual reading but a sudden spike, and that's after that we again get the value of 25 and 25. So that outlier spike we need to filter out through the median filter, and for that reason we first of all sort the samples, which is a absolute step to do. And if you remember the exponential moving average filter and moving average filter, we were not doing any kind of sorting in that, but in this median filter the sorting is very important step. So we sort all the readings, and you will see that our outlier goes at the end of the value. So we are getting a stable readings as pretty sorted. So the median value will be our actual reading, which is in our case the 25. So let's go down and see how it works in the actual median state. So we get 24 and 25 250, which is not our actual reading. So our actual reading is 25, and that will ignore the extreme values from our input. So our final stable output is 25.1 centimeter. So that's how the median filter is going to work. To implement this filter in our code, we created another array which is a filter size of 7, and we are collecting the samples like this. So it means that whatever the steps we are getting from the reading from this ultrasonic sensor, we are getting the correct 7 samples from this sensor through this Arduino. So we created another function to read the raw distance, and we put all of our ultrasonic reading logic to this function, and inside the setup we are doing pretty much same. Inside the main loop, we are doing a rolling window in which we are shifting the array, removing the oldest sample and adding the newest, and move all element one position back to make more space to add a new value inside our array. We call this read raw distance function to get a new centimeter value, and we are placing this value at the end of the array. Then we are creating a temporary array to sort. So because we don't want to sort the main buffer, so we create a temp buffer with the mem copy function, and we create another array to make it sorted. And after that we are applying a median filter through a median filter function, and after that we are just putting that to a serial print line, and we are displaying on the main OLED screen. So let's see how it looks into our actual display. So that's what it is going to be displayed through. If we change the distance, it is pretty much not giving a sudden outlier whatever we move the sensor. So it is pretty much stable like that. So it is not spiking even though I am moving the ultrasonic sensor, but it is not giving that such spike suddenly. This is due to the median filter effect. Let's move back to the actual median filter, how this is working. It is pretty simple, that we are bubble sorting algorithm, and inside that we are doing a simple bubble sort because our array buffer is just 7, so bubble sort will do fine. We don't need a complex sorting algorithm. Then we are just simply applying the median at the center of this sorted array. That simple bubble sorting algorithm will take all the time to calculate the median filter. I forgot to put the print line statement at this, and that's why it is not being plotted on a serial plotter. So let's put the end line character and re-upload the code. Now that the code is being uploaded, let's open a serial terminal first and see how it is working. Okay, the terminal was already open, so I closed that and reopen the serial monitor, and that's how you can see the reading is pretty much stable. And if you go back to our visuals, as I move this, the reading is changing gradually. So that's how you can see what is happening with this reading. Now let's try to plot these values. Here you can see we opened the serial plotter, and now the reading is not getting that sudden spike. So I move the ultrasonic sensor and it displayed what is the actual reading, and that's how it is changing through the actual distance. So here you can see now the values are pretty much that stable. So that's the power of the median filter, because you are seeing a pretty stable reading. If you look at this setup, you will see that the value is changing accordingly. Now you are not seeing a sudden outlier, instead it is just getting a steady output. So yeah, that's pretty much all for today's tutorial, and see you in the next one, where I will be explaining all about what I'm going to do with the next filtration.